Thank you, Lindsay. So thank you all for joining us for this 2021 Student Symposium Continuing Education Seminar titled Know Your Flood Risk, Flooding Sources Go Beyond FEMA Maps. Before we get started, please let me share a few technical instructions with you. If you're having any technical problems, please visit Zoom support at support.zoom.us or type your question in the chat box. The recording of this seminar without permission from ASCE Texas section is prohibited. All participants are muted throughout the duration of the seminar. If you have questions, please type them into the chat box in your control panel. Questions will be addressed at the end of the seminar. Next, let's enjoy this short message from 2021 Student Symposium Advocate, Nino and Moore. Now, I am pleased to introduce our presenter, Dr. Andres Salazar, Director of Water Resources Engineering for Walter P. Moore & Associates. Andres has more than 22 years of experience with planning and feasibility studies for flood risk management, drainage improvements, and water supply projects. He has special expertise in hydrologic and hydraulic systems that are key to creating an effective, sustainable site drainage design. Andres provides expertise and direction for flood risk assessment, site drainage, water recycling, and site water amenities. He also has extensive experience with complex drainage projects and is proficient with various software packages for hydrologic and hydraulic modeling. His education includes a civil engineering degree and a master's in civil engineering from Universidad de los Andes in Bogota, Colombia, and a PhD in civil and environmental engineering from Texas A&M University. Also, Andres recently received the ASCE Houston Branch 2020 Award of Honor. Congratulations, Andres. He and I have worked together at Walter P. Moore for several years, and I'm always entertained by his presentations. I hope you all will enjoy it as well. Thank you, Andres, for joining us today. Please begin whenever you're ready.
All right. Thank you, Heather, for your introductory remarks. So, yeah, I'm always pleased to speak at the ASCE event, and I've been speaking at the Student Symposium now for several times, and I always enjoy working with the students. So I hope I can provide very useful information that can help start building your career in water resources. Now I'm a water resource engineering. And flooding, as you can see here in this picture, is something I'm really concerned about. I think we have a lot of ground to cover, and there is still a lot of work to do here in the state of Texas as far as protecting the safety and lives of all the residents here in those flood-prone areas. So what you see there in the screen is a picture from Hurricane Harvey back in 2017. You can see the devastation. there. But this is not only a Houston thing, a Houston problem. There are many other places in the state that have these flooding problems. And in this presentation, there are many things in flooding that we can, as an engineers, can work on. I mean, can we do structural protection? Okay, can we build channel detention ponds or reservoirs? Can we do effective policy on how we handle the flooding? But there are many elements we can cover. In this presentation, what I wanted to do is talk about the risk assessment itself, how we communicate the risk, and are the tools available to communicate the risk accurate to determine that. So I'm going to put my presentation in the Houston, put as an example, put the Hurricane Harvey damages, but just keep in mind that all these issues that I'm going to be presenting here that are just applied to Houston are present in many other parts of the state, many parts of the country. So just be mindful of that. So let's start with a few statistics from Hurricane Harvey. No, it was a record 4-day rainfall in many areas. In one place, 60 inches were recorded. That's a record, no, of a tropical event in the United States. 40 counties impacted, $125 billion in damages. And then I want to highlight this last bullet. 50% of flooded structures were outside the designated flood zones. So after that, related to that last bullet, here are some of the headlines of the newspapers that you saw in the Houston Chronicle. Damage outside the floodplain exposes flaws. Well, the word flaws really is interesting here because I'm an engineer, and this article is really criticizing the work by engineers in assessing flood risk. So I really pay attention to that article. Flood insurance, few in Houston area have it, spurring calls to rethink floodplain maps. Number of flood insured on the decline. So all these articles were about criticizing how we communicate the flood risk, because when the resident goes and buys a home, they just go ahead and look at the FEMA designated flood zones. Okay, and they say, yeah, I'm outside this designated flood zone by FEMA, therefore I should be okay, right? And then Hurricane Harvey happened, and here you are with 2 inches of water into your home, and you were asking questions. What happened here? This map here, when I bought my house, says I'm not in a designated flood zone. I'm here. I am trying to repair my home. So all of these articles were kind of a criticism of that. I want to kind of expand that problem and explain really what happened there when it comes to assess flood risk in a property or in a city or whatever area you're working on. So to understand flood risk, first we need to understand that rainfall is what causes flood, and rainfall is a very variable element. It's random in nature, and you can have an event that is not 2 inches of rain one day, and then the next week you can have an event that is 16 inches in a few hours. So it's very variable and really hard to understand. There is some randomness associated with it. So let's start with rainfall. So you have there one of the many events that can happen in nature. This is a historical event that happened in Houston in 2009. So I want to start defining how we measure this rainfall. There are different metrics. You can start looking at, okay, the basic, how much rainfall are we measuring in that event? So in this event was a total of 7.12 inches. That's one simple metric, very easy to obtain. You have a rain gauge, you get that. The other metric on a rainfall event is the duration. Okay, you have these 7 inches of rain. Okay, for how long did it happen? Did it happen in 6 hours? Did it happen in 24 hours? And the duration is critical. It's not the same having the same rainfall event over a short period of time than over a very long period of time. So the duration is also a metric that we pay attention and we account for in our analysis. And the last one is the intensity. Intensity is measured in inches per hour. So in this event, you have you have very intense event. It was 1.92 inches per hour. So whereas other parts of the storm have a very low intensity. So once you put all that together, then you ask the question, okay, out of this combination, you have rainfall intensity, rainfall depth, intensity, and duration. What is a combination of things, of these three variables that can cause flooding? And really the answer is it depends on where you are. So if you have a very high intense event, um, you are more likely to see flooding in storms that are very localized, small drainage area. The storm sewer in front of your house, the storm sewer, the parking lot, for example. Those are systems that are at capacity with a very intense rainfall in a very short period of time. So that is something to consider, is the drainage area of your system relative to the intensity that may cause flooding. Duration, if you talk about duration, then it's log events that can cause issues in bayous and detention ponds and reservoirs. So you need a period long enough to start filling those bayous and start filling those reservoirs. And similar thing happens with depth. Now you can have not necessarily a long period, but you can have lots of water. And if you have a lot of amount of water, then you start dealing with conveyance problems. Like you really need to have a channel capacity that can evacuate that rainfall, that depth of water over an extended period of time. So your channels are what becomes a problem if you have a substantial depth, and depth is usually tied with duration. So and you can have an infinite combination of things. You can have high intensity, small depth, or you can have long duration and moderate depth. There is, if you look at these variables and you say, okay, how many possible combinations can happen? It's the answer is you have an infinity number of events. So when it comes to defining the FEMA floodplain maps, then they selected only 2 events out of this infinite combination. They selected the 24-hour event, 100-year, and the 24-hour event, 500-year frequency event. So those are it's something to consider. Is like when you have all this possibility of rainfall, there is only 2 hypothetical events that are accounted for in these floodplain maps. And in your hydrology classes, you're probably going to learn that, yeah, these events probably reflect all the other possible combination that could happen within that period, within 24 hours. So yeah, that's true. But the reality is all these FEMA designated floodplain maps are defined for only 2 specific events. So moving along, here is an example of a FEMA floodplain map. This is the end of the product. You take that event, the 100-year, 24-hour, put it into a hydrologic model. You apply things like the saturation of the soil, the level of urbanization, the topography, the capacity of the channels. You do your hydraulic models in the hydraulic model, HECRAS, do the analysis, and at the end of the day, you put that in some sort of inundation mapping, and this is what you get. So a closer look is like that. You have the cross sections of your river, and then you have a designated floodway and a designated 100-year flood zone and 500-year. Now we're using the 1% annual chance or the 0.2% annual chance instead of a 100 or the 500. But anyway, here's an example what happens. So the question is, no, okay, is this home here on 20th Street outside the designated flood zone, is this really safe or not when it comes to flood risk? And the answer is no. I think every property, every place has some degree of flooding. It can be low, or it can be severe if you're very close to the bayou. So really, when it comes to assess flood risk, we need to start looking outside this flood zone. This is just a piece of the picture. This is just a piece of the puzzle. It doesn't provide the complete picture. or what can be the causes of flooding for a specific property. So to better understand the causes of flooding outside this regulatory floodplain, let's go and start and look at how urbanization has evolved in the state of Texas. So this is a graphic statistics. You see the population in Harris County and that of the city of Houston. So you see there's 50% of the population in Harris County happens to be in the city of Houston. And I'm putting that in context because sometimes we look only at, okay, what happens in the urbanized area? And we think about cities as urbanized areas. Okay, the city of Houston, city of Dallas, Fort Worth, San Antonio. But we really need to start thinking about outside those cities. There is also a lot of population in the suburban areas that that urban, but not necessarily are recognized as such. So that's something to keep in mind. If you look, for example, at the city of Houston growth, you see there in the graphic the statistics. No, it was an aggressive growth over the last 100 years, in the last century, no, in the 20th century. So you can see there in the graphic a lot of that growth. The bulk of that growth happened between 1950 and 1980. No, that population was about 1.5 million people that were settled in Houston at the time. But if you look at the knowledge of the flood risk at that time, there was minimum. There was not so much information about the bayous, about the storm sewer, about the rainfall. So this is something. I'm going to explain something what happened there in the city of Houston. You have here's an example. This is an area in 1944. You see there. This is we can delineate if you pay close attention to the area. You can see a stream that just flows in this direction and goes to this gully and continues. So this is 1944 on the right and the left side of this slide. On the right side, you see the same area and a more present aerial view, but you can see what happens there. You see you have homes and streets and urbanization in the area where before you had the stream. So what happened is that and all this area was built in in an area that before was used as a drainage way. So something to consider there is the knowledge that these residents have at the time these areas were built. So looking at what can cause flooding outside the floodplain. So here I have different elements. You can have aging storm sewers and ditches. You can have flat photography and depressed areas. You can have overland sheet flow that is flowing into your property. You can have homes that were not built high enough. They are they are at a low elevation, or you can have a backward effect from the receiving stream. So all of these elements can contribute to a flood in a specific area. And not necessarily all of these are illustrated in a FEMA designated flood zone. So in Walter P. Moore, one of the things that we do not frequently is due diligence. Okay, there is a developer, they want to do a specific study here and there. Then we go ahead and go and do the due diligence and say, okay, what are the flood risks for this property? We look at the FEMA floodplain maps, but we also look at all these elements to really determine what is the flood risk for this property. Is it okay to develop? Is it going to be safe to develop? If it's not, then what do you need to do? Do you need to handle the overland sheet flow? Do you need to handle the elevation of the site? Maybe put your structures at a certain elevation so they are safe, things like that. So I'm not going to cover just one-to-one all of these elements. So the flat photography, flat topography. This is an example. This is the same area in the development that I showed before. So this is a slope of 0.4 feet over 1,000, 0.4 feet elevation drop over a distance of 1,000 feet. That is slope of that. That's that's very flat. That's nothing. If you go to other places like Austin, for example, and San Antonio, you may have more relief and rolling hills. But here in Houston, this is one of the complaints that we have is the flat topography, and there is no drainage. Um, Really, the water moves very, very slowly, and there you have ponding, and you have all sort of issues associated with that. The age of the infrastructure is another component there. So as I said before, we didn't have enough information when these developments, when these storm sewers were built. There was not enough information about what should be a good amount of rainfall to design this for. So this is you can see the level of the drawings, the level of detail of the drawings that were built 80 years ago, 90 years ago. There is just limited information there compared to today's standards. But this is an example. This is a 10-foot pipe. So you can walk into that pipe and still have somebody in your shoulders probably walking through that pipe. And still that pipe is not sufficient to carry the 2-year event for the drainage area that is receiving. So because at the time these storm sewers were built, there was not enough information. So it's something to consider, is that the age of the infrastructure can be a factor there. The other consideration is, this is very typical in areas like Houston. You have overland sheet flow coming from an area, and then you have the homes built too low. The streets is what convey the water, but the streets may not have enough capacity, so water starts overflowing, cascading down from one place to another. So homes needs to be at a specific elevation. So I mean, this is not a channel problem. This is not in the FEMA floodplain map. So this is something that you'll need to do a different assessment to understand what's going on there. Offsite overland flow is another element. Here is an example of a property that, for example, you want to do a due diligence. You see there the pink areas, the red pinkish areas are high topography, and more like the orange yellow are low topography. So if this is your tract, you're going to have to consider all this runoff that may come from adjacent properties and see how you're going to be handling that. And that's something that engineers sometimes overlook because they get contracted to do a work, and they say, okay, I have this 60-acre parcel and I have my boundaries. I'm going to look on my boundaries. I'm not going to go anywhere else. I don't need to go to my neighbor. This is something that is frequently overlooked. So you really need to start paying attention to the offsite drainage area that is coming to a specific property to better understand the flood risk. In that, railroads and roadways are usually barriers that needs to be accounted for. So this is an example. This is a cross section taken here. This is a railroad on this side. So if you take a cross section here, this is what you get. The railroads are elevated. In some cases, you have a difference that is 3 to 4 feet above natural ground. So something to account for is, okay, you have that sheet flow traveling on its way to a bayou or to a natural stream. It's going to hit a barrier there. Water is going to start ponding. Therefore, you have a flooding risk there. Okay, do you have enough? Do you have a culvert, for example? Does that culvert has enough capacity to carry that, to pass through that barrier? That's something that needs to be accounted for. So roadways and railroads are typically a problem as far as blocking the flows. The elevations of the homes are another element to account. This is an area that you can see the crown of the road, and you have roadside ditches. But if you look at the elevation here of this home, this home is in stilts, so you have it's elevated. It was elevated for a reason, because this homeowner probably saw that it was too low, and the next time this was built, then it needed to be higher. So you can see the elevation of the crown of the road relative to the elevation of the natural ground at this point. And if water is going to have to go on the roadside ditches, it's going to pond against the crown of the road, and it's going to spread over the lot. So something to consider when analyzing flood risk. The other element is design criteria have changed over time. So if you look at the criteria that was in place in the 50s, or now it changed in the 70s, and now it changed back in the 90s, and it changed again in the 2000 and 2020, it's a different set of rules. So when you look at a property that was built in the 50s or in the 60s, you look at the design criteria, it was probably, put it in context, it was probably designed for 4 inches of rain at the time, 50, 60 years ago. Now that standard is unacceptable. You need to start looking at maybe 16 inches of rain in 24 hours. That's a 100-year event. So design criteria has evolved, and the rainfall design has changed. And this is just a recent example there. In Houston, the systems were designed for a rainfall a rainfall of 13 inches in 24 hours. Systems that were built in the 70s, 80s, and 90s, early 2000s, were built with 13 inches of rainfall in 24 hours. That was the understanding of the 100-year event at the time. Now, the National Oceanic and Atmospheric Administration, NOAA, analyzed the statistics of rainfall for the region, considering the most severe events, Hurricane Harvey, and some extreme events in 2016, 2017, 2015, and they reevaluated what is the 100-year event, and they came up with a number that is 16.5 inches in some places. Some other areas have up to 18 inches of rain in the 100-year event. So this is a big jump. It's about 25 to 30% increase. So your understanding of the 100-year event change, which provides that started all the agencies, the cities and the county to start looking at, okay, what do we do with this? We need to increase our standards, design standards, to accommodate for this rainfall event. So you will see a change in the regulations. Now they're asking to put your homes higher. They're asking higher detention rates. So it's an evolution, and I don't think we are at a point that I consider this a stopping point. I'm expecting that all these rainfall changes and climate, we talk about the sea level rise and climate change and more stronger hurricanes, things like that, all that is going to be defining in the future how we handle drainage and flood control. So things keep evolving as far as policy and new data. We need to design with the best available data and all that. So I want to, this is one of my last slides here. This is an article I wrote in response to all these newspaper headlines. I sent my letter to the editor of the Houston Chronicle. It was published on September 11, 2017. And you can see my position on that. It is time to broaden the definition of flood risk because more properties in Houston are flood prone. The challenge ahead is to reduce and manage the risk, which will never be eliminated. It can be reduced, it can be managed, but I think the flood risk will never be eliminated. We need to really get a good understanding of the flood sources to really have a proper management of that. So conclusions here is that flood risks go beyond the FEMA flood maps. And we need to really understand all the sources, the age of your development, the storm sewer capacities around it. What time was it built, and was it built according to what standards? We need to understand the adjacent topography of the site. Does it have relief? Does it flow to your side or not? Does it flow away? Is there any barrier like railroads and roadways that can impede that movement of natural flow there? The elevation of structures. Are we building low enough? I'm sorry, are we building high enough? what is the correct elevation to set your finished floors? Do we need to start looking at, if it's already a structure put in place, do we need to start looking at flood proofing, for example? I think there was another presentation by my colleague, Doug Conning, about flood protection and flood proofing. So all of these, that's another piece of this element. What elevation do we protect? And then changes in design criteria. You know, if you're looking at a system and you're trying to assess the condition, I would suggest that you start, okay, what was the engineers required to do at the time they built this 40, 50 years ago, and how this has changed over time, so we can have a better understanding of how the design of flood risk has changed. So I think that's the presentation. And I think I have a full hour, right, Heather?
Yes, yes.
Okay, so
Now I will take some questions from the audience. You can add them to the chat. I believe we have one currently here in the chat, so I'll just bring that up. One of the questions is just concerns about, do you have concerns about roads flooding, even if buildings are not at risk?
yes.
For instance, in the Harvey event, people couldn't leave their homes because the roadways were flooded.
Yes. Yes, we need to comprehensively look at all the elements. This is not structural flooding. People die in roads, really, because they don't have a way out sometimes. And flash flooding, for example, low water crossings, it's a problem. And in Houston, the roadways are lower than the adjacent ground, so they carry the water. And if you look at the City of Houston criteria manual, they say, yeah, you can use the streets as a conveyance as part of your drainage systems. I think we need to look comprehensively at roadways and make the roadways are passable. There is some criteria that says, if you're building a new subdivision, access to that neighborhood needs to be passable. At least one lane, you need to have the opportunity for emergency vehicles to get in and out during a specific event, the 100-year event, and that's a requirement in many places. I think that's a problem that needs to be addressed, and I think solutions for that is, for example, implementing flood warning systems that you cannot change the roads. It's not easy to change the elevation of a road. That's a major endeavor. But if you understand a roadway can be flooded and cannot be used for evacuation, for example, then can you be a little bit more proactive and say, okay, let's put a flood warning system. Let's implement something that we know a storm is coming, we know a hurricane is coming. I think we have adequate technology right now that can tell us with some degree of certainty, okay, how many inches of rainfall are we going to have and when that is going to happen. We can run our models ahead of time and say, based on what I have, the information that I have today, I know that this intersection, this highway is going to be problematic in the next 12 hours. So can we issue warnings? Can we start doing like road closures, for example, or a heads up to people and the police and emergency vehicles to start planning for that? So that's something that we can do. No. So yes, roadway, answering your question, yes, roadways should be a concern, especially when it comes to evacuation. But I think there are ways that we can start managing and mitigating the risk.
Right, good question and good response, Andres. Here we have another question in the chat. I'll just read it here. Once we face these problems, especially infrastructure at low elevations, what are some of the actions engineers can take in order to address this problem?
All right, okay. So I would say the first is understanding the risk, which is going through all the possible sources of flooding and see how critical each is flood source to the total picture. Is it offsite drainage the problem? Is it the storm sewer capacity the major contributing factor? Is it a bayou that is nearby that overflows the contributing factor? So first understand what is the main source of flooding, if there is one or several. Then once you understand that, you can go and look into how you manage that. And you can have structural protections or non-structural protection. So structural, you go into flood protection, for example. Do your barriers, flood proofing, stop logs, floodgates, things of that nature. Raise critical equipment. If you have mechanical or electrical equipment in your building, can you elevate that to a safer elevation? So those are structural measures. The other thing that you can do is, if you know the building is flood prone and there is the interior, there are areas in the interior that can be damaged. Okay, can you do something to recover faster? Can you put materials that can inside your buildings? Can you put materials that can resist inundation? Can we reconfigure your space so that some places are going to be that your critical elements are in a dry areas and not in the flood areas? Can you start looking at issuing notices to your, if this is an office complex, for example, or a corporate campus, can you start putting policies? Okay, everybody's going to have the opportunity to opt in for a emergency alert system. If the place is not going to be accessible, then we will send you a text. So please don't come to the office if you get that message. So and we need to be creative. I mean, this is just a few examples, but if you can think of another way that we can manage the risk and keep people safe, please bring that forward. And there is all cards needs to be on the table. There is no limits here on what we can do to start managing the risk and mitigating the risk.
Andres, I'll add to that question. Very similar. What drainage improvements or solutions have we done before related specifically to aging infrastructure in a neighborhood? You mentioned, a commercial building or an office space, but what about neighborhoods, that have homes built lower than the roadways or have aging infrastructure? What are solutions we've provided?
Yeah, so we're looking at an area that has that specific problem. It's an area that is urbanized. Some drains do not have enough capacity, not even for the 2-year event. And there is really no place to connect to. So it's a challenge, it's expensive. So, but one of the solutions we're proposing is, can we just add a relief storm sewer, a parallel storm sewer, so that more water can drain out. The complexity that we're finding with that is that you put that storm sewer, you need a connection point somewhere downstream. So you need to have the capacity downstream, or you need to have stormwater detention. So you don't want to pass the problem downstream to your neighbor. You need to really manage entirely as part of the solution. So we're looking at, okay, can we add a storm sewer, or can we put stormwater detention that can accommodate that water outside the structures, and that water can be drained at a control rate. It's also a matter of policy. For example, if you need detention and you need to acquire properties, okay, it's a political decision there. Is this the correct move or not? But it's something to consider in the discussions. Is okay. I know that asking people to give up their properties for a drainage facility may not be easily accepted, but I think it's on the table. It needs to be considered. So things like that, detention, storm sewer upgrades, and then potential buyouts.
Yes, sounds like we have a lot of challenges related
Mm-hmm.
to flooding, especially in the Houston area. Good thing there are a lot of government aid that's provided, and sometimes for those drainage improvements that need to be done. I don't see any additional questions. I do have a follow-up comment about roadways flooding. Just to point out that TxDOT hydraulics manual does address roadways and flooding, the open lanes, as you mentioned, Andres, and other topics that you brought up. James brought this up in the chat. So in other words, yes, roadway flooding is considered by TxDOT. Here's one other question for us. Thanks, Sean. We do have a few more minutes left, so we'll take it. How have the results of the recently released ASCE Texas Infrastructure Report Card help with getting these issues elevated to our legislators? Also, please tell us how the Hurricane Harvey Task Force ASCE Texas developed helped.
Okay. No, the very, very good question. And as I said at the beginning of my presentation, there is still a lot of work to do when it comes to flood risk management and flood mitigation. And I think we're using this report as a good source of documentation, because the document was written by experts in the field and practitioners that know firsthand the magnitude of the problem. So I'm very supportive of the infrastructure report card, and yes, this is a very good tool that can help us to explain the magnitude of the project to the all levels of government, the legislature, the governor's office, municipalities, counties, really all levels of government can start looking at this report and say, yes, we do have a problem. We need to start doing something about this with the goal, over time, gradually, we will increase the grade as future report cards are produced. So yeah, it's a very powerful document, I believe. And then the flood mitigation task force. I'm also at the chair of that committee. That's an initiative, and I really appreciate the opportunity that the Texas section has given me to lead that effort. So that started back in 2017 when, as a professional community, we decided that we needed to act and really convey our message that something needs to be done, and we propose specific recommendations for that as part of the task force. And I'm pleased to see that some of these recommendations are moving forward. And I'm going to mention one specific is in that part of the report. In that report back in 2018, when it was released, we recommended that the state needed flood planning efforts at a regional scale, a statewide flood planning efforts. That was one of the recommendations. And if you have been following the news, then those planning groups now are moving forward, and they are now implemented, and they are, they have selected consultant engineering firms to start developing their regional flood plans. So this is one. I'm pleased to see that one of the recommendations is now fully implemented. There are others there in that increase levies, increase funding, use green infrastructure. There were 7 specific recommendations there that we still need to work with the legislators, make sure those are happening. And as part of this task force, we are just keeping track of the recommendations and engaging in the conversations with the development board and all levels of government to really push and be an advocate for the recommendations that we put together back in 2018.
Thank you. And Lindsay has posted a link to the Texas Infrastructure Report Card in the chat if anyone's interested and wants to take a look at that. there's also more information on who else volunteered in the committee. So if there's no other questions, I'd like to just thank Andres Salazar again for providing this technical presentation, and thank you all for participating and attending the seminar. Please visit the event schedule in the ASCE Texas Student Symposium Attendify app to access the Zoom link to join the keynote presentation, which begins at noon. The keynote presentation is titled Turning Failures into Success, My Civil Engineering Journey, presented by Annalie Martinez-Gonzalez at MWM Design Group. And then following that keynote presentation will be another technical presentation, Building Flood Resilience. That goes into detail on the flood protection solutions for these type of flooding challenges. So hope everyone can attend. Please share this information with your colleagues, and thanks again for joining. This concludes the seminar.
Okay. All right. Thank you, Heather. Thank you, Lindsay.
Thank you, Andres. Thank you, Heather. I am now going to stop the recording.